Hi, I'm Steven Salas, and we're talking about today about container security. But first, we're going to talk about a little about myself, a little bio. As I said, my name is Steven Salas. I'm a security consultant in Sorin Lab, Spain. I have 8 years in experience of network security, right? And since 2018, I've been working for Sorin Lab, Spain. Let's talk about a little bit first about what is going to be this talk, okay? Containers is a technology, right, that allows us to create an environment where applications can run independently of the operating system. And if we're going to talk about security, we need to secure every component and every chain of every piece of the chain, so we can keep secure our containers, right? Container security must be integrated and permanent, and that's what we're going to talk about today. We're going to see what are containers, how do containers work, what is the attack surface, what we can do to see what is going on inside of our containers in terms of security and vulnerabilities, what we can do to defend ourselves, and a quick summary of what we saw. So let's start. So what are containers? There are a lot of definitions online of what containers are, but as we said before, it's a way to package everything that you need, okay, to run an application or to set up an infrastructure for an application. If we go to docker.com, for example, it says container is a standard unit of software that packages up all the code and dependencies and everything that you need to run reliably an application from a computer environment to another. Containers are mostly everywhere. Without you are using containers when you use internet, when you use Facebook, when you use anything related to cloud technology, which is the big break of the container technology. And let's keep the head in the computer environment part, because the container technology came because we had some difference. Let's talk about maybe a scenario that we've seen before. Let's say that you are a developer application, right? And you need to pass the code that you have already done, and it's proven it's working fine, to another developer. When you pack up your code and send it to the another developer, he tries to run this code in his environment, let's say in a computer, anything that he has or she has to run. But all of a sudden, the code stops working or it's not working fine. Why is that? Because in the environment of the developer one that we can see here, maybe there are libraries, there are dependencies, there are upgrades made to anything that was used to make that code that is not on the developer 2 environment. So what can we do now? How can we establish a collaborative relationship while we're making a code? Well, we used to use virtual machines to do that. Let's say that developer 1 would build up a virtual machine with everything that he needs to run his code, and to pass it and to make sure that it's going to work, he passes it to developer 2. Developer 2 uses the hypervisor that he likes to run this virtual machine, and then we can talk about like in the same language. So sometimes that solution is not the best solution, and that's why containers are here. Let's see a little bit of difference between the containers and the virtual machines. As you can see here, we have virtual machines, which are the physical infrastructure, the physical appliance, the device that you're going to use, right? Inside this device, we're going to have, this device could be a laptop, could be a server, could be a virtual server in the cloud, could be anywhere. Inside this this device, we have an operating system. On top of that operating system, we have an hypervisor. The hypervisor, what does is it handles the virtual machine, handles everything related to virtualize that pack of software that you have there. Inside that hypervisor, you can run these guest OS that you see here are the virtual machines and are different operating systems running on the same physical device. On top of that, we have the binaries and the libraries that we need to run the application. And at the end, we have the application. This model or this way is fine, but it takes a lot of space. As you can see, you have the hypervisor, you have the different operating systems, which could be a lot of information that you might not need because there are things on the operating system's guest OS that you see here that they're not useful for the code. So what can we do now? We can use container technology, which is pretty much the same as a virtual machine structure, but with the difference that the operating system is not running an hypervisor, it's not running the container engine. The container engine sums up what we need to use the container. You don't have to use the whole thing that the operating system comes with. So once you have cut this amount of data, you have a very lightweight container, or you have a very lightweight package with all that you need. What you need the binaries and the libraries and the actual application. So this option becomes the best and the simplest way to deal with this problem that we see before, this one right here. So now with containers, you can make this faster and you can involve more people into the development, and the communication and the pass of information becomes easier, way easier. We've been talking about right now about containers as the concept, as the whole, as how they work, but we haven't talked about the major, let's say, providers of this technology. On this side, we have OpenShift, which is owned by Red Hat, is a container solution that you feel free to use whatever you want. But in this case, we're going to talk about Docker in general. Okay, we're going to talk about the best practices, how can we deal with containers with this technology, and this is pretty much applicable to OpenShift. The major difference here is that Docker is open source, it's free, you can download it and use it. OpenShift because it's part of Red Hat. There are a few things that you need to get a user, or maybe you have to pay something. You have to deal that later. And a lot of things that you need to do here, maybe in terms of security, let's say, maybe in OpenShift is already integrated. We'll dig into that later. So until now, we've seen which is the difference between containers and virtual machines. Now we've talked about Docker. Let's say what is the three components that help us make a container. First of all, we have a Docker file. The Docker file is like a recipe. In that file, you have everything that you need to create the actual image. An image is not only the operating system that we've seen here. It's a lightweight operating system that is used to run your application. Beside of that, we have operating system and anything that you need. If you need uh, uh, web servers such as Nginx or Apache, you can declare it here. This is your manifesto, what you need to build your image. Once you're done with that, we build an image. The image has everything that you need to run a container. You can use an image multiple times, and it's not only could be custom made for a specific container, or you can use a general image to run different versions of different things or different containers. Okay? Knowing that, we need to know the bigger picture. What is the basic taxonomy of Docker? We've seen before that we have our Docker file, our Docker image, and our Docker container. But we've talked about base OS, the base operating system that is going to use to run the container. So where does Docker get that operating system from? There's a thing called registry, which is basically a storage, which could be on cloud or on premise, that all of the images that you have. You can have Ubuntu, you can have CentOS, Red Hat, anything that you need on the registry. From your computer as a Docker user, you can download those images or those containers from the registry so you can use them or modify them to use it as you need. So the registry stores all the images. The image is the base OS that is used to build your application or support your application. And the Docker file is the configuration file. This flow of information here becomes a security issue, since, as you can see here, this registry is public. It's actually called Docker Hub. You can go online, you can search and type dockerhub.com, and you'll see a website where are all kind of images stored that you can use. The problem with that is that in the registry, you have not complete control, because it's public. You have not complete control of the image, so you can download and upload images as you need. So this is a security issue because you are not sure what are those images back up, and you don't know what user did and what did to the image. So you don't know if you're downloaded a safe content or a safe base OS that you can use. We'll dig into that later, but it's very important that we see where's the first problem of this basic workflow. Okay. Now, we can have our private registry, as I said before. We have the Docker Hub, but we also can use our cloud provider users, to create a registry. And in that way, we are very sure that the information that is uploaded there it's okay. So we have services for Azure, Google Cloud, Amazon, AWS, Quai or Red Hat. These are all solutions that we can use, or we can create our own to mitigate this registry problem. So until now, we know that containers have images, have Dockerfile, have a registry. There's a workflow when you can upload and download images from the Docker Hub website, but you can have your own registry with your own images. So until that, we're doing great. Now, we need to point out one thing. As I said before, you have an image, and from that image, you can create different set of containers. Let's say you have an image one, you have a base image of base OS of Ubuntu, and on that you have run a web server called Apache, and you need to have, let's say, 3 containers or 4 containers or more than 1 container. You don't have to make a Docker file or a base image for each different container. You can use the same one when you can run different containers. Now, what is the case of use of this? Let's say in this case that you have container one running Apache over Ubuntu, and you have a small website that you build on your own, and you sell some things there. It's like a e-commerce website. All of a sudden, something happens, and you start to sell a lot of your product, and you're doing well. But this container cannot take the load of all of that requirements. So what can we do? We can duplicate this container in container 2 or 3 and load the balance between them. This is not only made with Docker. With Docker, you can build the containers, but if you want to do that kind of load balancing and stuff like that, you'll need something called an orchestrator. The orchestrator is watching every time that the container is up, and if it's not up, he can bring up whatever the system needs to keep everything up. We'll not discuss that here, but this is the way the containers work. The main advantage of this is that you already have all of your infrastructure loaded and set up. You don't have to set another container from scratch. You have already done, and you only have to bring it up. So this is another good way to see this. It's lightweight and it's fast. Let's say in this other scenario, we have an Ubuntu with MySQL, an image with that, and we have this database to support my website here. We have container 1 that runs all the requests and handles all the let's say the traffic, right? And all of a sudden, this container was attacked for something, for a malicious, for a malware, for someone, and we have to bring it down. But we need our site up, so we can bring up the container 2 to keep doing the job while this container 1 is rescued, let's say. Or maybe you have container 1 when you deal with all of your database traffic, and at one point of the day, you bring up container 2 and 3, and you replicate the information from container 1 to 2 or 3. So this brings us a little bit of flexibility in how we can use this the fastest to make our projects or applications run faster and be simpler, let's say, to handle. Now that we've seen that, we've been talking about what are containers or what they do, how we can use them. Let's say the security part. Let's say that we need to see what goes inside and what is the attack surface. What can happen if my container is under attack. So let's start, and we're gonna have to slow down here because we're going to show a few attacks and how they work and how you can stop them. But until we do that, we need to know what are we exposed to. The first of all is loss of availability. This is a very common problem in security nowadays, that you have a website on, and for any reason, political issues or another kind of problems, your site is down. So maybe that site is running in a container and your container is down, and you have no way to bring it up because you don't have a backup or something like that. So the containers are, let's say, vulnerable to loss of availability or of a denial of service attack. Also, the loss of confidentiality. There is a way that you can attack a container and use the CPU power or the processing power which is running the container, and use that for maybe crypto locking or crypto mining. I've seen that, where a container and lots of containers are infected with malware, and that malware is mining Bitcoin, Ethereum, or something like that, using this small amount of CPU power. But if you distribute that attack among a lot of containers, so then you have the availability to do that. So also the privilege escalation inside the host. There's a way when you can have control inside a container, and after that you can go out of the container and go to the host machine and gain privileges inside of the host machine and start to do whatever the attacker wants with that host machine. So there's a container escape known attack. So we'll be seeing into that. Also the compromised host. This is the worst case scenario when an attacker gains control of a container and after that moves to the host machine. And once he's there, he gain root privileges and start exploiting vulnerabilities from the host machine to the host machine or other machines inside that network. So it's a pretty let's say critical security issues that we're going to dig into that and see how we can, without any help of any software, just best practices and good configuration, we can stay away from those cases. Now let's talk about the attacks from the actual attacks. Let's talk about C groups. C groups are it's a enhancement. It's a feature included into the Linux kernel that can help us to limit the amount of process that can be handled by a container. So let's say that we have a container, and that container is made only for one purpose, and that one purpose requires only 2 processes running inside the container. So with C groups, we can limit the amount of process running inside that container, so we can make sure at the whole time that the container is doing what it's made of, what it's meant to be doing. So from this way, we can keep attackers away from the crypto mining and crypto hijacking or software encryption. Anything like that is not allowed because the kernel of Linux is not allowing that to happen. Let's see an example of that. We're going to use here, we're going to see examples of commands. Now we have our host machine, which is called Docker. We're going to run a Docker container, right? We call Docker from Docker run. This is the command for running a container. -itd, that means that it's interactive, so you can have a shell once you have the container is up. And with this flag right here, we are invoking the C group feature when we're saying that process IDs, because it's plural, dash limit to 6. And we're going to use Alpine, which is the image, the base image to run this container. So now we have started our container, and we start to look inside of what is going on inside that, what resources is being used by this container. We can see first the container ID. We don't see that here, but this is container ID that is running. The network information and the memory usage and the limit, and we have the PID part. This parameter right here, as we said here before, we are limiting these PIDs to 6. How we can be sure that this is actually happening? If we run in another terminal and a shell of the container, we're trying to run 7 commands. Right? We're going to run 7 commands, and because of this limit, we won't be able to see anything or a response from the container. Let's say we are creating here. Just a second. The color of the pencil is red. Okay, we have command 1, command 2, command 3, command 4, 5, 6, and 7. If we stopped here, only put 6 command, maybe it would work. But because we have made the input of 7 commands, we have the resource temporarily unavailable. This means that this container is not able to run more than 6 processes at a time. This can come very handy when you have a very limited resource host machine, or you have to keep an eye on the container to see what are the process that are running inside of it. You can also see what I don't have the output here, but you can check what are the actual process, not the number of process, but the actual process that are running inside of it. And you can stop them if you need it, to make sure that the processes that are running are what is meant to be. Okay. Now let's move to C groups is done. Let's move to namespaces. Okay, let's say that you have a container that it's running, and you have the real bad luck to have that container attacked by someone, and that someone is inside of the container, and inside that container is running with root credentials. Okay, as you can see here, there's a little diagram. You have the container, it's in black. Sorry, the host machine, which is in black, and you have the container in white right here. And that someone, here is an attacker, but could be someone else. Doesn't matter if it's an attacker or not. You have the attacker inside the container with the root privileges. Okay, the group ID where it belongs is 0, which it means that is root user. Okay, and once he is inside, let's recreate the issue here. We're moving to the container. Sorry, let's start over. This is the scenario, right? Now we're going to go to the host machine and try from root user, try to create a file and try to change it, and then see if this attacker right here can make changes to that file that was created by the host root. Clear this. Okay. Now we are on our host machine. We switch to root user. We check that we have our root privileges, which are right here. So we are root inside the host machine. We move to the TMP folder, and once we're there, we create a file that is called file.txt with the content I am from host. Once we made that, we check that the permissions for this file are only writable by root. These are WP right here, means that only root can make changes to this file right here. So no one else, just root can do that. We try to make sure that this is the real scenario. We log out, and we as a simple user, we try to make a few changes into the file. What we got permission denied. This means that is running good. Only a file here can be only changed by the root user. We're doing fine now. So let's move, let's run our container. And this time we're going to run our container, but we're going to mount this folder right here, that TMP. We're going to mount it into the shared folder of the container. This means that everything that is inside this folder right here will be visible into the container from this folder right here. We check that, we execute our container, we see that we are root user inside the container. We move to the shared folder, and we see that file.txt is there. Now, let's prove that actually or the what we saw here, that only root user into the host machine can make changes into the file. We try to do a little change into that file, and we don't see any error, which is odd. What does this mean? If we go out and we see the file into the host machine, and we see that changes were made from the container to the file into the host machine, this means that when you are root inside a container, you are root inside the host. And this is a very it's a very bad problem. So this should be, at all times, you should be isolated. One of the advantages of containers is that you are supposed to be isolated from the host machine. In this case, we see that is not. By default, is like this. We have to make sure that this doesn't happen anymore, because if someone is root inside a container, can come to the root and start doing whatever he wants inside the root, the host machine. We cannot allow that. So the answer is very simple. What we can do to stop this? First of all, we have to stop our Docker daemon or Docker service, let's say, and start it over. We start over, but now saying that our Docker daemon or Docker system, we're going to use the namespace and remap it to the default profile. This default profile will keep everyone inside of their environment. So root user inside a container will be only root user inside a container, and root user in the host will be only user in the host. They cannot change, they cannot modify anything inside their own, outside their own software systems, let's say. So now we've done that. We have done some changes into we're remapping the namespace. We're going to use the same example, and we'll try to do changes to that file.txt. This is inside a container, and we see that we are root. We can see it right here. Inside the container, you're root, but if we try to do anything, even read the file into the host machine, you see that you have no permissions. So right now, this means that root inside a container is not root inside the host. This is a very useful technique to keep everything where it belongs to be. Okay. Now let's talk about capabilities. Capabilities as root into a Linux or Unix system, you have all the power that you need to run anything that you need inside that system, right? But all the powers that you have inside those systems are, let's say, segmented in different files or powers, if you will, which are called capabilities. Capabilities are the powers assigned to the root to do things inside the system. But there are ways to keep root users away from certain capabilities. Let's see how that works. In Linux, as you can see here in the output, you see that capabilities are, let's say, named like this. cap for capability underscore shown. Shown is a change owner, means in Linux. You can change the ownership of a file or anything using this command. Because Docker is made out of Linux, you will see that the capability in Docker is named actually almost the same without the cap part. And these are all the superpowers that you have. If you run a capsh --print, you can do it in your Linux system, and you will see the capabilities that are assigned to your user. When you run Docker, you also have some capabilities, and are mostly inherited from the host user. And sometimes they're not. You can play with that. So you can make sure that root users inside a container are not able to be root inside your host system, but also to don't have all the powers that your root user in the host has. So if we raise this right here, let's start a container, right? But this time we're going to use this flag right here, hyphen cap drop chown. This means that this container will run, but the capability of change owner won't be available for the root user. So if we run our container, and from the root, let's remember that this hashtag means being root in a Linux system. If we try to use the chown capability or command, trying to make this file being owned by nobody, which means that it can be seen from anyone inside the computer, you'll see that you have this operation is not permitted, because as you saw before, we saw that the first capability here was chown, but this is inside a container. If we run capsh again, we'll see that chown is no longer there. This means that because we have set this flag during the start of our container, this capability is no longer there. But the rest of the capabilities are there. So if you're trying to make a profile of the root user that you need to run a container, you can check this out, and you can make, let's say, a superpower profile user to run your containers without the fear of this root user can be going inside your host user or having a power that you don't need them to have. So this is a way to keep this away, to keep the bad guys away. Now the privilege flag. As we talked about before of the capabilities, we have a privilege flag while we run our container. Let's say we're running a container without this privilege flag right here. Let's say a Docker run a -ti alpine, and inside of that container we're going to run capsh as we saw before, and we see that these are the capabilities that are coming from that container. We see list, right? Which has all the capabilities. But what happens if we run this command again, but with the privilege flag? What does this mean? That when we run the capsh command, we'll see a very longer list that you see right here. This means that the privilege flag gives the container and the user inside a container way more power than a regular root user if we run it without the privilege flag. Some containers, because of the nature of the project or the application, have different needs or profiles that need more capabilities than the root has. So sometimes developers use this privilege flag to they don't want to think about the permissions and anything. They want the application to work fine. So they give the privilege flag, so the container has all the power that it needs to work fine, and they don't stop to see which capabilities are being given and which capabilities are needed by the container. So if we're able to make a list and profile, as I said before, with the capabilities, we have a better security for our systems. Okay. Now, so far we've seen what containers can do, what they cannot do, which are the major security problems that we can find into our containers. But what about the things that we're not able to see? What about the things that are already inside the image? Let's say that you didn't know about this before, and you downloaded an image from Docker Hub, and now you're suspicious about maybe that image wasn't that clean, and I need to know what's going on inside. So there are tools on the internet that you can use to check that information. There are tools that give us the ability to see what is inside our containers. They're giving us the ability to see if there are vulnerabilities associated with anything inside our container. So these tools can come very handy to do a vulnerability assessment. So here are a few names of software, of tools that you can use. First of all, we're going to start with Docker. Docker Bench for Security. It's a project that you can download for free from their GitHub site. I think I have it at the end of the presentation. You have the ability with this tool to see the tool. What does is runs a checklist of better practices or better if the configuration made to that specific part or file or anything is okay and is compliant with the security standards. So we have a little output here that shows this output here shows us how can the checks are being made. In this case, we see a pass because the Linux kernel is updated. We have another names here. This is Trivy from Aqua. This is Anchor. All of this is download for free from their websites. I encourage you to check them out and see if you like them. Okay. Now, we're going to see the defenses. We have three defenses that we can use. Besides all the things that we said, we have AppArmor, which is a software that gives us, let's say, a whitelist or blacklist of what commands that or permissions that the user can have into the container. So in this profile right here, we have denied the access to the TMP folder and the etc password file. So we can run our container right here. We'll see that if we try to do anything to those locations, we'll see that we don't have permission for that. So you just have to build a profile, and it'll work. Okay. We also have seccomp. Seccomp is the same thing, but this time the profiles are made with JSON. And in this particular example, you see that what is been forbidden for the user is to use the chmod, which changed the permissions of a file of the user. And if we apply the profile to our container, that we see that chmod is forbidden. It's not able to be used, but chown, as we saw before, is available. So you can be very granular with this kind of tools, right? Capabilities is another way to keep us safe, we have control over our root users. We saw that before, so it's only mentioned here, so that we can use this kind of defenses to keep our containers safe. Okay. Now, very fast summary. We have known what are containers, how this container works, what is the problems of security that we find on the containers world, and how we can stop them. If you need, please, any help or any documentations, feel free to go through these sources. I don't know, maybe this is going to be able on internet, but this is the sources that I used to make this talk. And if you have any more questions, please go to the 101 room, where we can be talking a little bit deeper into that. Thank you very much.